In question 17, we have a battery connected to a variable resistor and a voltmeter connected across its terminals. When the variable resistor has a resistance of 6 ohms, the voltmeter reads 4, and when the resistance is 10 ohms, the voltmeter is 4.4 volts. Calculate the EMF and internal resistance of the battery. Okay, let's draw the circuit again to help us to visualize the problem. Okay, the variable resistance of value R, and then you have a battery source, okay, with EMF E and internal resistance of small r. Okay, when the circuit is connected, the current is I, and we have a voltmeter that is connected across the terminal. Okay, when the variable resistor has a value of 6 ohm, the voltmeter reading represented by V is equal to 4.0, and when the resistor has a value of 10 ohm, the voltmeter reads 4.4 volts. Okay, so we can use Ohm's law V equals to IR to help us to solve for EMF and R. Okay. Okay. From Ohm's law, we know that the EMF equals to the current that is flowing in the circuit multiplied by the internal resistance plus the resistance of the variable resistor. From the first scenario, we can calculate what is the current I that is flowing in the circuit, okay, when the big R has a value of 6. From 1, okay, using Ohm's law, I is equal to 4 over 6 amps. So we substitute this into the equation. We have E into equation 3. Okay, substitute into equation 3. We have E equals to 4 over 6 small r plus 6. Okay, so this will give you 2 over 3 r plus 4. Okay, equation, let's say call this equation 4, and from 2, the current is equals to 0.44 amps. Okay, we substitute into 3 again, so you get E is equal to 0.44 R plus 10. Okay, so you have 0.44 R plus 4.4. That's equation 5. Okay, by solving equation 4 and 5 simultaneously, we will obtain the values for R first, okay, you will get a value of 1.76 ohms, okay, by subtracting 4 from 5, okay, and then you can get the E by substituting the value of R in 5.17 volts.